Welcome again. Our next topic is decisions or control statements. So decisions or control statements basically help us to decide among different possible paths. So if there are multiple sets of instructions and they all need to be executed under different conditions, so we can make use of that condition in the decision making and then execute the set of instructions that are appropriate for that particular scenario. So the tools that are available for control statements are goto, that comes from the old C language. Then we have if statements and switch statements. So they are going to help us in deciding one among multiple paths, and that is going to be supported by some decision making. We would come to the goto part as it is very inefficient and has many problems due to which the other approaches were being introduced, but we would touch on it. Before this, let's just talk about the if statement. If statement has got multiple variants, so we may either have a simple if statement, we can have an if else condition, we may have an if else ladder, and we may have nested ifs or nested even if else's. So these are the different variants of the if statement. Now how this single if works is that if we have a set of instructions and then we reach a decision, in that case if the condition is true, if it is yes or true, so we are going to perform this separate set of instructions and they are going to be together, and then we have some other instructions to perform. So only when this condition is true, these instructions are going to be executed. Otherwise it's not going to do anything, and they are going to straight away, in case of false, it's going to come to these set of instructions. So that's how the if statement works. In case of if else, we have a set of instructions, then we have a condition. If the condition is true, so perform this set of instructions. If the condition is false, we have a separate set of instructions, and then the rest of the program is going to have some more instructions. So that's how the if-else condition works, where we have a separate set of instructions to be executed when this condition results in true, and another set of instructions that would be executed when this decision results in false. In case of the if-else ladder, we have some instructions over here, and then we have the condition. If that condition is true, execute this set of instructions. If the condition is false, then we have another condition. If that is true, then execute this set of instructions. If it is false, then check on this condition, and the same way it works in the form of a ladder. We would see how we are going to code this, but for now we just are focusing on the concept of it. And then we may have nested if else also, which would be like having multiple if statements nested within one another. So if we have a set of instructions, then we may have a condition which, if results in true, we have this set of instructions, but over here we have another if statement, and that would lead to another if statement, and we may have some statements over here to execute, but there are multiple if statements nested within one another. So for these statements, this condition has to be true, and for these statements, these both conditions have to be true. In the same way, we can have multiple if statements nested within one another. The same way we can have multiple if else statements nested within one another. For example, in case of else, when this is false, we may again have another decision, and in case of it's true, we would do something else, and when that is false, we would do something else. So that's how if and else may be nested within one another. Then we come to the switch statements. Switch statements are basically a form of having a ladder type of if-else statements. If you have multiple conditions, then a ladder if-else statement isn't going to look very good. So switch statement would make that a lot readable. In case of switch statement, we are basically defining different cases, and within each case we have a set of instructions to execute. So it's basically more like the ladder if else, but in this case the code, as you would see later, is a lot more readable as compared to the if else statements. So it's basically another version or another way of doing exactly the same thing. Goto statements do not have any decisions, but they would help you to get to a particular set of instructions, and for that you just need to provide the label, and without checking any condition or anything, it's going to jump to a different part of the program, execute that part of the code, and then come back here. So if you have like a set of instructions over here, and then you have the goto statement, so as I said, it's not going to check on any condition, and then it can jump to a different part of the program, execute those statements, and then another goto statement would bring it back over here. So that's how it works, but due to its inefficiency, it's not commonly used. So now let's try this in code. Okay, so we would start with our skeleton, and let's just say int a equal to 5. So an if statement would be if a is greater than 5. So as we are using relational operators, so it's going to result into a positive thing or a negative, and then we say cout a is bigger. So that is our program for now. We will add another cout statement. So it printed this statement, however, since a is not bigger than 5, the condition was false and this statement was not printed. So that's how if statement works. If the condition is true, it's going to print this statement, otherwise it's going to skip this, and this statement is going to be printed in all cases because it's not part of the if statement. If we make it greater than or equal to, now this statement is going to be printed, which is within the block of the if statement. So now it prints a is bigger, and we have executed if statement. So now it has executed both the statements. Let's add an and L to it to make it look good. Okay. Now what if we would want to have both these statements as part of the if statement? If condition has just one statement, so we may present it like this. Indentation is just for the code readability, but if we have multiple statements within the if condition, then we have to use brackets in order to define a block of code, and we would put these statements within the block, and now both these statements will only be executed when this condition is true. So that's how the if statement works. We'll just execute to see the results. The condition is true and both the statements are printed. Next we would look into the if else case. So we would just add the else statement to it, and again if else has got just one statement, so we can write it straight away, or if we have multiple statements to execute in case of else, so then again we have to define a block for it. So let's assume we have just one statement, so we would say the else case. And now if we execute this, of course it's going to execute the if part because the condition is true, but if the condition is not true, then it's going to get to the else part. So now we have two different set of statements to be executed when the condition is true or false. In case of the later if else statements, so we are going to define another condition over here. Let's say a is greater than 5 and a is even. That can be identified if a mod 2 is equal to 0. So we are checking on two conditions now. If a is greater than 5, it's going to execute these statements. Else, if that is not the case, we are going to check on another condition, and that is if a mod 2 is going to give us a 0, which means if a is an even number. If that is true, it's going to print this statement. We would say even, and we will write another else statement for this if, which is cout odd. So if we execute this, it says odd. So first it checked on this condition that was false, then it came to the else case and checked on this condition which was again false, so it came to this else which was associated with this if, and odd was printed. So as you can see, it's in the form of a ladder and it's going to keep on checking on conditions one after another until a condition is met. If none of the conditions are met, it's going to execute the last else case. So that is in the form of a ladder. In case we want to check on nesting if statements, so just like this is an if statement, we can nest an if statement within this. So we would see if a is greater than 5 and a is greater than maybe 10 also. So if that is the case, execute this statement. Now if the first if condition is true, we are going to come to this if condition which is nested within the outer if statement, and if the second one is true, this statement is going to be executed, otherwise just this statement will be executed and it's going to exit the body of the if. So that's how multiple if statements can be nested within one another. So that was a case of nested if statements. I'll just add the equal to sign to it to make it true. So this condition will be true, then this condition will be tested, and it will skip this statement because a is not greater than 10, but this part will be printed. We have executed the if statement and this part was printed, and the second if statement was resulted in false. So these were the different possibilities of the if statement. Next we will try the switch statement. As we said, a ladder if statement makes the code look ugly because there are too many conditions and probably indentations, so that is going to take a lot more code. So we can do the same in fewer statements and the code is going to be more readable if we use switch statements. So for that we have to use switch keyword. So we'll define its body, and now we have to provide different cases. So case 1 is, let's say, cout a is 1, and the same way we can add multiple cases. Case 2 is cout a is 2. So this way we can add multiple cases, and as you can see, case 1 is basically the condition if a is equal to 1. So this is a lot more readable and cleaner as compared to the if statements. But another important thing is that after each case we have to enter break statement in order to make sure that after having one true case, it comes out of the switch statement and does not check the other conditions. Just like we had the last else in the if-else ladder, we can have the default case. We would add a break after this one also, and then the default case is presented as default, and cout a is bigger than 2. So that would be the default case, that if none of the cases are true, this statement is going to be executed. Of course, there is no need for break after this because there aren't any other cases after this. So that's how we can write the switch statement. And it says a is bigger than 2, of course, as all the cases were false, and it came into the default case. What if we want to display the same statement for multiple cases? For example, if you say for 1 a is smaller, for 2 a is smaller, for 3 a is bigger, break. Case 4, cout a is bigger, and in the default case we would say a is unknown. So we have a repetition of these statements under different cases. So again, this is repetition of code and it's not good. It takes more effort, so we can basically cut down on it by merging multiple cases together like this. So in this case, either the case 1 or 2 is true, it's going to execute this statement, and break is going to bring it out of the switch statement. So this statement would work both for case 1 and case 2. The same way we can combine case 3 and 4, and this statement is going to work for both the cases. If either of the condition is true, it's going to execute the statement, and we would add a break after this as well. So that's how the switch statements work. So a is unknown, of course, and if we write a is 2, so it says a is smaller. So that's how the switch statement works. And next we are going to look into the goto statement. Of course, it's not a reliable way to write your code. It's going to introduce different problems, but just for the sake of demonstration, let's see how it works. Int a is equal to 5, and then we say label. So we have assigned this particular name label to the next set of instructions. So if I say cout a, and over here if I say go to label, when we say go to label, so it's going to come over here and print this statement again, and since there isn't any stopping, so it's going to do this continuously. So let's just see how it works. It continues to print 5 because there isn't any stopping criteria. It's getting back to this part and is continuously printing the statement. So in order to come out of it, we may write another goto statement, and that has to be after this because we want to break this loop. And over here we may define another label, let's say next, and we would say go to next. So now it will come to this part of the code. It will go to the label, it will execute the statement, and then it will come to next, which is after the label, and the loop is going to be broken and it's going to print the statement only once. So 5 is being printed and the code ends. So this is how the goto statement works with these labels. Whatever we write and put colon after that is going to be named as a label, and the statements after that are basically the part of that label. So that's how the goto statements work, and that's all about the control statements.